So we can because the parents are not taking everything down. So 3, 5. The reason why I should put that, which is the reason, there's no combination. Yeah, there's no combination. So you have to solve it to a particular step by which combination. So this makes it that and that. So 3, 5, 2, 8 ways. So the unit of combination and permutation is ways. The number of ways something can be done. From this combination, that means you can have, which is 4 men, that's it, just 2. The left it was men. The first one says we have to make a community of 6 from these numbers, from 10 men and 8 women. And from this 10 men and 8 women, 4 is taken from men, then 2 is taken from women. That's this one. But now the question now says, with this, in this same particular way, how will the 2 women is included? But we are still to take what? 2. Now that means 2 men have already been taken. That's now how do you now take 4 men from that just 9 from 4? Just this one. Because 2 women are 4 men, right? But now 2 particular women from it. That's combination of 2. That's what we do statements. In how many ways of this 2 particular men are already been taken? Their condition. Those that are taken from total number of men. That means we are left with 2 men to make it 4. The remaining ones, the remaining 7. That's why we have 7 combinations 2 times. But the women is not being affected. And this gives us, we have this one about 6 factorial, 2 factorial. So this one gives us 7 factorial, 5 factorial, 2 factorial. 6 times 5. 7 6 times 5. 7 times 6 times 2. Then multiply by this one. If you do that, that's all you get. 5 88 ways. So that's the first statement. It's a combination by which you take something from a particular combination. For example, number 2. letters, learning. It can be anything. It can be statistics, it can be mathematics, it can be probability, and the number of ways it can become. I'm sure you've seen this before. That's 1, 2, 3, 4, 6, 7, 8, 9, 10. The total number is 11. That's 11 factorial. Now, if there's any indicates B is twice. That's 2 factorial. R is twice. That's also 2 factorial. That's all, right? So when you have some probability, can be those equations like statistics. If it's statistics, C is 3 factorial. C is 3 times letters. That's what the total letters divided by the number of times. It can also be in mathematics. That's also 11 factorial. N is twice 2 factorial. A is twice 2 factorial. C is twice 2 factorial. Now, so that's the arrangement of those letters. It's anyone that repeats it. So we solve this, then we get an answer. So calculator. Just by 11 times, 10 times, 10 times, all the way to 1. Or we also have a factorial multiplication. Now, if you want to also complete together, how do we arrange? Now, when we want to arrange this one, we are going to treat I and I to be one thing. Because we do together. So if I and I are together, then B and B are together. How many letters do we now have all together? That will give us 9. Now we have B, that's 1, R, 2, 3. B and B now has now become 1, making what? 4. A is 5. I and I have become 1, making what? 6. L, 7. C, 8. Then Y, 9. Do you understand? Now, for I and I to be together, we treat it as 1. So making 9 factorial total that we have. But now, when we now do that, for I can also be, I is 2 now. The first one can come first, and the other one can come first, right? It can be I or I. That was 2 factorial, 2 ways, right? Then B also, B can be B or B, just like the arrangement. Although they are the same letter, or one can come first. So this is what we are going to do now. It's going to be, now we said treating B to be one thing, then I and I to be 1. That means everything will be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 9 factorial. So that would be 9 factorial. That would be 9 factorial. Now, since there will be no repetitive words, since this B and B has become 1, and I has become 1, there is no one that is being repeated. For now, the B and B, they are 2 factorial, right? So we multiply this one. Then I and I 2 factorial. So now multiply this one. So this is how we solve this. P, R, O, that's 3, that's 4, 5, 6, 7, 8, 9. That's 9 factorial. But the B repeat itself twice because it can be big B or big B. Based on this arrangement. That's for this one. This is also for I. Assuming they are 3, now 3 factorial. So this is how we solve the answer. So you can have the letters down. In some cases, the questions might be simpler than this. But knowledge of other questions helps you solve this. So this is not part of the question, but this question is also important. And the question is, how many ways can 7 people be arranged in a row? And how many ways can they also be arranged in circular table? So we have arrangement in a row and arrangement in circular table. Now, for arrangement in a row, this is a row, right? Now, for arrangement in a row, it means if there are one, they can change, first one can change, second one can change. It just means what 7 factorial. So arrangement in a row is just how many are there? Factorial rows. That would be what 7 factorials. But in a circular table or in a circular ring, we are going to make it so to be that one person will be at a particular point. Then the other 6, right? The other 6 are now sitting in different ways. So this one will be the formula for circular arrangement, this permutation. So for circular, let me start with the row. So for row arrangement, for arrangement row, just n factorial. So 7 people to sit in a row, that's what 7 factorial. Get your answer. Like 7 times 6 times 5, all the way to what? 1. But in circular table, I said one person started, right? Then the other 6 can be arranged in different ways. So it's what? Just n factorial. So that just want to check that in. Then we have number 3. Because I'm going forward, I'm taking some questions. Students, there are 7 sides and 5 words, 5 parts. Now, what are we selecting? You have the question with you. So, 12 students. Of 5 is this, right? 5 is what you want to take from this total students. So 5 is to be selected. And to find the number of restriction. What do you mean by there is no restriction? They can pass. So when there is no restriction, the number of students taken we don't know whether, we don't want to know whether they are science or they are arts. So when there is no restriction, it's just 12 combination 5. Means for no restriction. That means 5 students to be taken for what? 12 students. When there is no restriction. Restriction means it doesn't matter whether they are arts or they are students. That's how we solve for this one. Then use your normal computation method to get your answer. Then the second one says, at least 2 science students are included. At least 2 science students. Now, how many students do we need in total? 5 students, right? Now we have to get, now X now is at least. This 3 science students. At least 3 science students. What does at least mean? We have 3 students. We can have 4 and we can have what? 5. Don't forget, we are selecting 5 in total. At least means we can have 3 or more. So we do for 3, we do for 4, we do for 5. Now, if we are having 3 science students, that means we are going to look for 3 science students and what? 2 arts. To make them what? 5. Then we also look for what? 4 science students and what? 1 art. Then we also look for what? 5 science students and 0 arts. But 0 arts will give us 1. Like 0 bacteria will be 1. So we just look for the 5 now. So at least 3 science students means 3 science students and 2 arts. 4 science students and 1 arts. Then 5 science students. That's the meaning of at least. You can see at least, at most, exactly, not fewer, not less than. It can come in different statements. You just have to know what each of them is. So this for at least 3 science students. Now, that means we are selecting 3 from 7 science students. That's 7 combination 3 times 2 art students from 5 art students. That's 5 combination 2. We solve for this one, then we add it to the next one. 4 science students now. That means 4 from what? From 7. 7 combination 4 times 1 art student, 1 from 5. 5 combination 1. Then for 5 science students, that would be 7 combination 5. So we solve for this one, we add it, whatever we have, we add it to this one, then we add it to this one. That will give us our answer for at least 3 science students. So if we solve that, what do you have? $546, right? So that's for number 3. Now the number 4. A, we are given probability of B. We are given the probability of the union. We have to find the probability of the intersection. And after that, the second part. Then we ask if they are independent or not. So two events A and B. So we are given probability of A to be 0.6. We are given probability of B, and we are given their union. Now we have to find the probability of their intersection. Now, this is the formula for probability of intersection. We are going to get minus this. Am I right? Probability of intersection. The addition of the probability of A and B minus the union. Is it correct? Correct. Now the P of A plus P of B minus P of A union B. So this is the formula for the intersect events. You have event A and event B. It means probability of event A plus probability of event B minus the probability of the union of the event. And so some of you see that type of question in your test. You can also see it in maths too. It's also important from the analysis. Yes. All right. So now for this one, it means we have 0.3 minus 0.75. This is your 0.9. 0.9 minus 0.7. That's 0.15. Right? Now, the probability of the intersection is 0.15. That's the first thing we have to find. Now, we are now asked to find the probability of A slash B. Now, for this one, for this, it will be the probability of the intersection divided by the second one here, that's probability of B, divided by the probability of B. That's for A slash B. Now what about probability of B to A? That's the same probability of intersection. That's how we between. Probability of intersection divided by probability of B. Probability of intersection divided by probability of A. Now, intersection is 0.15, and probability of B is 0.3. Our intersection for this is also 0.15. Probability of this is 6. If we solve that, the first 0.5, right? 0.5 and 0.25. Now, to know if it's independent and to know when it's dependent, this is what we check. If the probability of A is equal to probability of B, and the probability of B slash A is equal to probability of A, this is independent. But when it is not equal to, it's going to be what? Dependent. So now, based on what we have here, the probability of A slash B is not probability of B. 0.5 is not 0.3. And probability of B slash A is not probability of B. 0.25 is not 0.6. So which means this one is what? Dependent. It's dependent. In other statements, they can also write it like this. They can say it is not independent. This statement is the same thing. It's dependent and it's not independent. It means next question, number 5. It says a bag contains 7 red, 5 blue, and 8 green balls. So these are some questions that you can easily see in your questions. 7 red, blue, 8 green. Total number is 20. Okay. The first statement says 3 balls are drawn at random without replacements. Without replacement means once you remove one, the total number has reduced. So without replacement, X is the event, which is 3 balls. Now, find the probability. Red. Find the probability that all 3 are red. Yeah, this is the normal probability that we know, right? If you take red ball the first time, you are going to 7 over 20, right? How many red balls? There are 7 red balls. Total number of balls is 20. So if you take red ball one time, you are looking for the probability that all 3 balls are red. So we take it for the first time, that's 7 over 20. Is it times or addition? Huh? Is it times or plus? Times. If you take it the second time now, total number of red balls has reduced. And total number of total balls now has also reduced. That's 6 over 19. Then if you take the third time, that will be 5 over 18. You get the answer for that one. And if you multiply that, what does it give you? So our answer for that first one, that gives us what, 7 over 456. That was it. Times 5 over 18. Okay, 7 over 2 weights. Now 2 are blue. Now if 2 are blue and 1 is green, blue first, that's 20 times 4, 19, that's 2 blue and 1 green times 8 over 1. I just want to check something. If you take blue first before red, and we take red, okay, blue and green. We take blue first before green, and we take green before blue. We still have the same thing as this. Am I right? You can check now. Okay, let's say we take green first. If we take green first, that's 8 over 20 times. Now, if you now take blue, that would be 5 over 19 and 4 over 18. You still give us the same thing. You take green first or blue first, you end up working. So that's for this question. Our answer gives us times 8 that's 4 over 17, which is 0.022. So that's the probability of false selection without replacements. Assuming it is with replacements, the 20 will not change. It will be 7 over 20, 6 over 20, 5 over 20. But without replacements, the ball replaces. The ball replaces. So that's number 5. So the next question, probability of as we continue, let me take this question. The probability of an event, it ranges from what value to what value? The probability of something we have for not say negative, and you cannot see a number greater than 1. I'm sure you might see that in your test. And in one of the questions also, it said which of these is not a probability, or which of these probability cannot exist. There's 7, there's 2 over 5, there's minus 1.5, and there's none of the above. So which one is the answer? Although there are 2 answers to that question. What and what? 7 and minus 1.5, right? But which one is the main? So that's the minus. So you cannot have negativity. So that 7 and 0 is everywhere. This one. But that minus is totally. You can never have negative. Now, number 6 says the probability that it hits on a particular day is 0.4. So the probability that it's rained today is 0.4. So the probability that it's raining is 0.4. Now, if the probability, we have, by the time we get there, we have probability of success and probability of failure, right? If P is the probability of success, Q is the probability of failure. Now, and how do we get Q? Q is 1 minus what? P. Q is 1 minus probability of success. So if the probability of success of something happening is 0.4, the probability of it not happening is 1 minus 0.4. So if it's 0.4, then Q is 1 minus 0.4. And that will give us 0.46, right? That's the first statement. So the probability that it's going to rain on a particular day is 0.4. And probability of it not raining is 6. Now, if it rains, the probability that a student is late is 0.7. If it rains, probability of lateness for rain, like today now. So the probability of lateness for that rain is 0.7, right? So the probability of lateness that is rain is 0.7. And then the probability of the person not being late, right? We also look for that one also. That's Q for lateness. That is Pn. That means this one will not be what? 0.3, right? So when you have probability of something happening, you surely have probability of it not happening. So probability of it to rain is 0.4, of it not raining is 0.6. The probability of lateness is 0.7, probability of delay is 0.3. Now, the question continues. If it does not rain, the probability of being late is 0.2. We are already given this one 0.2 instead of 0.3. Probability of lateness for it to be rain is 0.7. The probability of, if it does not rain, the probability of late, we are given as 0.2. So this is how we answer the question. Probability of it raining is 0.4, of not raining is 0.6. Probability of lateness when it's rain is 0.7. Then when it does not rain, probability of lateness is at 0.2. So we use these two. Now, the question now says, find the probability that the student is late on a particular day. The product of probabilities, like what then is late on a given day. So probability of lateness is this, that's 0.4 and 0.7 plus, I'll explain again. The probability that it's going to rain on a particular day is 0.4. Probability of it not raining is 0.6. The probability that if the rainfall is given parameters. Now the probability of a student being late particular day is that the product of this and the product of this added together and you get an answer. And if you do that, what do you have? 0 points. 0 points what? So what answer? 0 points. 4. That's obtain some combination and probability. But the main part of the courses we did this semester is discrete random variable and continuous random variable, Bernoulli and binomial distribution, approximately position and so this is just an introduction to what we're doing. And number 7 is of discrete random variable. So we'll be expecting more questions from this one because this one you might just see some of them. But this one that is main focus. Okay. Before we continue, let me also chip in this question. If a coin is being closed 3 times, what's the probability of getting at least 2 heads? If a coin is being tossed 3 times, if you toss a coin 3 times, what's the probability of getting at least 2 heads? How do you solve that? What's the answer? You right? If the coin is being tossed 3 times, what's the probability of getting at least 2 heads? The question should not be as simple as this. Just simple statements. One about it. Now, if a coin is being tossed 3 times, what's the probability of getting at least 1 head? 2 heads. I'm not 1 head, 2 heads. Huh? 4 by 8. That's 4 by 8, that's 1 by 2. Look at this. So how do you do it? First of all, we know that a coin has head and tail, right? Head and tail. Now, if head and tail, that's 2, right? How many times is being told? 3 times. That's 2 raised to power 3. This is the first thing to know the number of outcomes. That's what? 8. The total number of outcomes is 8. If a fair die is being toast 2 times. Fair die is having how many pieces? 6. That's 6 raised to power 2. That's what 36. That's why you know that everything is 36. So if a fair die is being toast once, that's 6. Twice, 6 raised to power 2. 3 times 6 raised to power 3. Same thing to a coin. Coin is having just 2 faces. If it's been toast 3 times, that's raised to power 3. 4 times, that's raised to power 4. So that's the first thing you know your number of outcomes. Now, for at least 2 heads, outcomes of you can have head, right? Then the other ones head, tail, head, right? Then you can have 2 tails now. Head, tail, head, and head. Tail, head, tail. Then you can also have tail. 1, 2, 3, 4, 5, 6, 7, 8. Completed. 3 heads. 2 head, then 2 head. I do the same thing for tail. 2 tail, then 2 tail. That's what this thing. Then 3 tail. Like this 3 now. 2 heads at one side, 2 heads at one side, then 2 heads separated, tail in between. The same thing for 2 tail, 2 tail, then 3 tail head. So at least 2 heads means you can have 1, 2, 3, 4, right? That's what 4 over total outcome 8, which is what 1 over 2. Now, assuming the question says at least 1 head, what's the answer? At least 1 head. You what? Wrong. At least 1 head. Based on this now, at least 1 head. Huh? 7 over 8. At least 1 head. All this is having head except this. That's 7 over 8. Do you understand? Now, what's the probability of having exactly 3 heads? 1 over 8. Exactly 2 heads. Exactly 2 heads. Exactly 2 heads. 3 over 8 now. Exactly 2. 1, 2. 1, 2. 1, 2. That's 3 out of 8. Please, this is very important. So number 7. So number 7 now. We have discrete random variable. So the question says, a discrete random variable x in PMF. What's the meaning of PMF? PMF. PMF. No, we have PNF and we have PDF. So what's PNF? You can start from this so that we can move. Okay. So when you see it, let me know. So a discrete random variable x has a PNF of this. Now, it means we have the distribution function, the probability function now. What's that n? That's in between. Alright. Now, we are given the probability when x equals to 1 is what? 0.1. Now, we are going to get it in tabular form as this. These are x, these are p of x. Now, when x equals, we have 1, 2, 3, 4, 5. Now, when x equals to 1, number 7 now, that's what we have. When x equals to 1 is 0.1. When x equals to 2 is 0.25. When x equals to 3 is what? K. When x equals to 4, that's 0.3. And when x equals to 5, that's 0.15. Okay. Now the first question says, find what? K. Now, when you are dealing with discrete probability, discrete random probability function, so when you are dealing with discrete, P of x is equal to what? 1. You know that the probability, the total sum of the probability of, you know, we said probability between 0 and 1, right? So the total probability must be what? Must be 1. Now, if P of x must be 1, that means everything here must be 1. So that means this plus k plus this is equals to 1. So what's the value for k? K is 0.3. Is 4, 5, 6, 8, 3, also. Right? Because this one we give 3, this and this, that's 4, that's 5, 6, 7, 8, 22. So 0.2. So k is 0.2. Now the second statement, what are we asked to find? So the second statement, we are asked to find probability of x greater than or equal to 3. Probability of x greater than or equals to 3. Greater than or equals to means from 3 upward, right? Now, this 3, you know our k is what? 0.2. Now, from 3 upward means including 3. That's what the equal to means. So this means this plus this. That is 0.2 plus 0.3 plus 0.15. And that gives us what? 0.65, right? So that's what, for discrete, continuous is different. For discrete, this is what you do. So from 3, it says greater than or equal to 3, that means from 3 upward. If it's downward. Now the next question says f of what? F of what? Of 3, right? Now f of 3, where is the position of 3 here? This place. Now what's the probability of f of 3? Means from 3 downwards. But 3 itself included. Do you understand? F of 3 means from 3 itself downward, not upward. If you just have f of 3, what's the probability of f of 3? Not p of 3. Assuming it is p of 3, p of 3 is just 0.2, right? But f of 3 means from 3 downwards. If you have f of 4, from 4 downwards. So f of 3, that's 0.2 plus 0.25 plus 0.1. And that gives us 0.55, right? Am I correct? That's f of 3. Now the next question says find e of x. Downwards. Downwards means like 3, 2, 1. That's what I mean by downwards. Up 4, 5. Don't get it wrong. Downward. So the question is now find e of x. What is e of x? E of x is same as what? Mean, right? They can also give you this symbol, mean. So we have to find e of x, which is the mean. Now, what's the mean of discrete random variable? That's summation of x, p of x. This for discrete. Summation of x, p of x. Summation of x, p of x. Now, how do we get x, p of x? Now, if you just come to your table, x, p of x, meaning multiply x by p of x, then add them together. That's your mean. Just like your normal mean of, or this one, you are not dividing by a total number of, just multiply, then add them together, you get your answer. If you multiply this, you have 0.1. If you multiply this, you have 0.5. If you multiply this, you have 0.6. Multiply this, you have 1.2. Multiply this, you have 0.75, right? Then you add them together. That's your e of x. So e of x is what? So e of x is what? Yeah? 3.15. So 3.15. Now, there is another part of the question that is not added there. So I want to keep it in. It's variance. Now, v of x is the variance. Now, the question can also say find the variance of this discrete random variable. Now, the variance of this discrete random variable is given as e of x squared, right, minus e of x squared. That's the variance of discrete random variable. Variance v of x is given as e of x squared minus e of x everything squared. This e of x talks about what? The mean. It means minus mean squared. But for us to get the variance, we must first look for this one. E of x squared will be summation of x squared of x. That's e of x squared. Now, instead of multiplying x by p of x, we are multiplying x squared by p of x. Now, what does it mean? It means, let me do it at this side. So, x squared p of x. It means, what's x squared here? 1, right? 1 times 0.1 is still 0.1. Now, what's x here? That's 4 now. Squared it. That will become what? 4. Then 4 times this. It give us what? Huh? 1, yeah. 1.0. Now, the next one, x squared. Now, that's 9, right? Then 9 times this gives us what? 1.8, right? This one becomes what? 16. Then 16 times this, that's what? 4.8. Then 5 squared becomes what? 25. Then 25 times this, that's what? 3.75. Then you add everything together. That's your E of x squared. Now, E of x squared is now what? If you add them together. Yeah? 9.45. That's the summation of this. 0.1, 1.0, 1.8, 4.8, 3.75. 10.45. 11.45. So 2% are right. So 11.45. Okay. Now 11.45. That's E of x squared. Now, how do you now get this? So you now say 11.45 minus, what's the mean? 3.15 squared. What's 3.15 squared? Now, what 11 was answered? Yeah? 527. So that's the variance. That's how you get variance and the mean of discrete random variable. But you have to get the constant k. That's how you do. That's how you get constant k. Making sure that everything is what 1. Then you get your k. Now after getting your k, you can give you probability of something like this. You can even give you probability of x less than or equal to 3. If it's less than or equal to 3, that means you are taking from 3 downwards. So this one can be anything, but based on what you have there. They can give you this one. It means from 3 downwards. Then you have to find the mean and the variance. So that's for discrete. Then we also have for continuous. Yesterday's question that I wasn't able to finish from number 8 to 15. I've actually done it, so it should be online. I don't think it's been uploaded yet. Next one. Oh, if it's not there yet, you see it from number 8 to 15. You see it on my YouTube channel. Now the next one now. A continuous, now this one is continuous, not discrete. Now a continuous random variable y has a PDF of f of y equals to 2 into 1 minus y. So f of y equals to 2 into 1 minus y. Now we want to do the continuous. In this continuous random variable, we are going to apply integration. In the continuous, we are going to apply integration. Now, the random variable y has a PDF of f of y equals to this. For 0 less than or equals to y less than or equals to 1. 0 elsewhere. Now, what does that mean? It means the integral of f of y, which is 2 into 1 minus y, as it tends from 0 to 1. That's what the statement means there. The integral for continuous is integration. So the integral of f of y, this f of y now, as it tends from 0 to 1, you can see 0 less than or equals to y less than or equals to 1. So that's from 0 to 1. Now we have to check, is it valid? You can also see a question like that, we have to, is it valid or not? Now how do you know if the continuous random variable is valid or not? If it is valid, now this is first, we have the integral as it tends from negative infinity to positive infinity, f of x, the x, it should be equal to 1. Just like discrete random. You So the probability of discrete random variable must give us 1. Now, if this function is also valid, if we integrate it as it tends from whatever it tends to, with respect to whatever we have there, it must give us what? 1. So let's check if it's valid or not. Now we have 2 into 1 minus y. Now in its integration, if 2 should we multiply or just bring it out? Let's bring the 2 out. So that's 2 into right. That means we have 1 minus y, right? 1 minus y divide. Divide, the reason I put divide is because with respect to y, not with respect to x. 2 is the coefficient. If we integrate 1, it will give us what? Integrate 1 with respect to y, it will give us what? 1y, right? Just add y. But it tends from what? 0. Let me do it this way. That will be y. It tends from 0 to 1. You know, these two will affect everything at the end. That's minus. Now, if you integrate y, it will be what? Y squared over 2. Because y here is used for 1. So the integration, add 1 to the power, then divide by the new power. So that will be y squared over 2. 0 and 1 also. There will be no plus c, right? Now, this page now, what the tensor means when you put 1, when you put 0. But you know when you put 0, it will be 0. So you don't have to do for 0. So that means you are going to have 2 into, this one will be 1, right? 1 minus what? Yeah, yes. 1 minus what? 1 over 2. Am I right? Is it correct? This one is 1 to be 1 squared. That's 1 over 2. That's 1 minus 1 over 2. I said what it tends to 0. You don't have to do for 0. What's half? So 2 into what? Half. And that gives us what? 1. So which means it's what? It's valid. So if you're able to get 1 from the integral of the function itself, with respect to whatever it's there, what it tends to, you must get 1. That means the PDF is valid. Now, the next part of the question. You have to find P of y greater than 0.6. Now, P of y greater than 0.6. What does this mean? The function is said, let's write it again. We have 2 into 1 minus y dy. Now, this one will determine what is true. Part of the question. This, whatever, it will determine what it tends to. Now, in normal cases, I'm also saying this one first time. But in normal cases, you have it like maybe 0.2 less than y, less than maybe 0.8. In normal cases, it will be like this. So if it's like this, that means we are going to have 0.2 towards, right? But now something different. Now, what does this greater than 0.6 mean? It means you have from 0.6 to what? To 1. Because it has to be from 0 to 1. That's the main question itself. So if you have y greater than 0.6, that means from 0.6 to 1. So the lower point here will be 0.6, and upper point will be 1. Is that right? Now we now integrate at the 10 from 0.6 to 1. Now let's do that. 2 is out. just like what we have here, right? Now divide into 1 and 0.6. I mean, then minus y squared over 2 into 1 and 0.6. I'm sure you know how I get that part. Just like representation of that. Now this one, now we are going to use the 2 points, the lower points and the upper points. We use both the lower points and also the upper points. Affect everything later. That will be 1 minus what? 0.6. That's what we have here. It means when you put the upper points minus when you put the lower points. It's just y. That will be 1 minus what? 0.6. That's the first one. Now minus, which is this one. Now when we put 1, that will be 1 over 2, right? 1 square. 1 square over 2. That's 1 over 2 minus 0.6 squared over what? Over 2. That's what we have for this question. When it turns from 0.6 to 1. So we put the 1, then we put the 0.6. When you put 1, minus when you put 0.6. Same thing here. So if we solve this, we are going to have 2 into 0.4, right? Minus 1 over 2 minus 0.6 squared divided by 2. Solve, then solve, and solve. What's our final answer? Final answer 0.4. 0.6 squared gives us 0.36. And 0.36 divided by 2 gives us 0.18. Huh? So if we continue, that's 2 into 0.4 minus 1 over 2 is 0.5. So 0.5 minus 0.18. That's 0.32. Then 0.4 minus answer. That's 2 into 0.08. I mean, then times 2. That's 0.16. Is it correct? So that's for that question. That's the second part of it. As I said, you might see questions that are simpler than this one. It will even be simple. No, seriously, it will be simple. But the way to form just be somehow. So as we are reading the tougher ones, go down a little to read the simple ones. Because simple ones at times can be shocking. Like I've read everything and it just brings one small, but it can even be from the formula. They've just said, how do you know if the PDF or the continuous stuff is valid? You're not saying, is this 0, is it 1? You've seen 0, you've seen 1. You know what it is, it has to be 1. So something like that. Now the next part says we find the mean, then we find the variance. Okay. Now, we want to find the mean. Now, the mean of a continuous random distribution. So, the mean is E of x. Now, it's a different formula. So, it's the integral as it tends from negative infinity to positive infinity. X f of x dx. It's almost, if you check, it's almost like discrete. In discrete, we said x p of x. Here also x f of x. So this is what the mean. Now, how do we get the mean here? Now, what it tends to will be the question itself, not the second part. The question itself, which is from 0 to 1. So that means we are looking for the integral from 0 to 1. X. Now, we are not dealing with x, right? We are dealing with what? Y. So that means we are doing y now. That's, let me change it. Y, f of y, dy. It means the same thing. That means we are multiplying by with f of y. F of y is what? 2 into 1 minus y. Right? Dy. So this one is what we are integrating. Then we get an answer. That's what the mean means. It means multiply y by the function itself, then integrate it. If it's x, multiply x by the function itself, then integrate it. Now, if you multiply y to this, initially we are going to have 2 minus 2y, right? Like if you expand the middle one. So if y now multiplies, that means we are looking for the integral of 2y minus 2y squared. Am I right? But still, I think 1 will still be out. So let's just bring out 2 will still be out. Let's bring 2 out. 2 into y minus y squared. Is it correct? If y multiplies this, it's still 2 into y minus y squared. Do you understand? If 2 multiplies, that's 2 minus 2y. Abi? Then y now multiplies, that's 2y minus 2y squared. But I now factorize 2 out, that's y minus y squared. So that we just bring the 2 out as coefficients. Then we continue. Now, if you bring the 2 out, now as it tends from 0 to 1, divide. So that means we are going to have 2. Okay, if 2 is out already, we have got 2 out now. So 2 into, now, derivative integral. So if we integrate y, that's y squared over 2, right? Y squared over 2. As it tends from 0 to 1. Minus, if we integrate y squared, that's y raised by 3. Add down to the power, divide by the new power. That's y raised by 3 over 3. Tends from where? From 0 to 1 also. Integration of this and integration of this. So I said the lower point of 0 doesn't matter, but it's the 1 that we now use. That will be 2 into. If y is 1, that's 1 squared. That's 1 over 2. Minus. Then if y is 1 here, 1 over 2, right? Do we understand this? Which part should I explain again? No question. So 1 over 2 minus 1 over 3 gives us gives us 1 over 6, right? Then, so 2 into 1 over 6, 2 here 1, 2 here 3, that's 1 over 3, right? Yes. So this can be our answer, or in a decimal place, that's 0.33. So that's mean of continuous random variable. That's for the mean. Then if it is the variance also, we still repeat the same way and solve. I will just give the formula for the variance if you have to do the variance because of time. Now, if it's the variance, v of x, it's almost like this one. V of x is e of what? X squared, right? Minus e of x all squared, right? Now, what will now be our, no, this one is our main, this is this one, right? Now, how do we now get this one? To get this one, now for this particular question, we need the integral as it tends from 0 to 1. Instead of y, it's not be what? Y squared. Into 2 into 1 minus y. The y. So this is what you use for the variance. So by the time you get this e of x squared, just like the normal way, put it to this formula and get your variance for the sake of time. So that's discrete and continuous random variable. That's that one. Then we have the Bernoulli and binomial distribution. So as I said, I'll be chipping in some questions as we are going forward. Now the next question I want to chip in is this. Tomorrow we are meeting as early as what time? So that we can finish quickly. Even to me, the time is not convenient, but I'm sure that's the time that it will be better for us to start. So tomorrow we'll be doing, if not all the diagrams that we've done, I will provide the sketch for everything. And there's one that I've not really done like that. I will also do that. So, but tomorrow we'll draw as many of those assignments and classwork as possible. So if anyone, as you are joining it, if there's anyone you have a question, it's just be like a personal class, just for you to draw. But if there's a step you did not get, I will explain. And for those that didn't know what to do, I will also explain. Why the last one? So that's what we'll do tomorrow. I said I will chip in some questions. Now, if there's a feather, if a feather, it can be a feather or unbiased, it means the same thing. So if a feather or an unbiased guy is being closed twice, if a feather is being closed twice, singular is die, plural is dice. So if a feather is being closed twice, what's the probability? The sum of the outcome will be equal to 6. Sum of outcome. If a feather is being closed twice, what is the probability that the sum of its outcome will be equal to 6? If a feather is being closed twice, what is the probability that the sum of its outcome will be equal to 6? The class we did yesterday and what we are doing today, the video is available on this week. You can check it out, and you can send the those that will not have to you. You can go to them. So if an unbiased or a feather is being closed twice, what's the probability that the sum of its outcome will be 6? Yeah? 5? Is that right? That's right. So for a feather, you must know those. I'm sure you know use that, right? The outcomes. So for a feather, you must know those outcomes often. What's the outcome of a feather? You have from 0 to no 0. You only have from 1 to 6. So you have 1, 1, 1, 2, 1, 3, 1, 6, right? 2, 2, 2, 3, and others. I'm sure you know what I'm talking about. I'm talking about this. Everything giving us what? 36, right? 6 is about 2. 36 outcomes. Now, to know when the sum will be 6, we just check from here, right? It just be like this is how I do my. We used to play that game. That word person. How many are there? 1, 2, 3, 4, 5. Is that not all? Is there any other one that will give you 6? No. So 5. That's 5. Total outcome is what? 36. Now with this same question, let me teach you something. Which one of them give you the sum of 7? Probability of getting sum of 7. 1/6, right? How do you get 1/6? This for 7. Right? This one. 1, 2, 3, 4, 5, 6. 6/36, which is 1/. Now the question, you can have, if it's objective, you can have 6/36 and 1/6. You can have 6/36 and 1/6. So what do? The simplest form. Your fraction must always be the simplest form. It's very important. Now what if the question can be in different forms, but once you remember this, you can answer any question on fair guy toast twice. So that's for that question. So I'm just trying to achieve it for better understanding. Now the next question. Now, number 9, if you are there. Now we are given that a binomial random variable x has the parameters n equals to 9, p equals to 0.4. Just 2 things. Write the PMF. I was asking earlier, what's the meaning of PMF? Probability what? Mass. So the PMF is probability mass function. So we have to write the PMF of this question. Then after that, we have to find the probability of x equals to 2 and x equals to. And now let's start with this. Now, he's talking about binomial. Now we have to get the probability of this binomial. Okay. All right. So we are given that n is 9. What is n? N is total sample. Like total, no, not sample. Total population. Sample is different. Now n is total population. P is the probability of success. Now, if probability of success, remember I said that the other time. If probability of success is 0.4, Q is what? Probability of failure, right? And Q is what? Now, how do we get 0.6? 1 minus 0.4, which is what? 0.6. So, because we need to get that, you'll be given only probability of success. You need to get your probability of failure from there. Now, how do we get the PMF of binomial distribution? This is how we get it. P of x is given by what? Forgotten. N combination x p raised power x q raised power n minus this formula is very important for binomial. N combination x p raised power x and q raised power n minus x. That's for binomial distribution. Binomial distribution. Now, how do we now get the PMF of this question itself? Now the probability now is now this. Our n is 9. That's 9 combination x, no value of x yet. Like the PMF. PMF means like the function, the formula that we're going to use. So P, our P is 0.4, that's into 0.4 raised power x into 0.6 raised power 9 minus x. This is the PMF of the question. So the PMF needs to get the formula that relates those parameters together. Polynomial distribution is P of x equals to n combination x, P raised by x, then Q raised by n minus x. So that's the PMF. Now the next question now says, find the probability of x equals to 3. We have to find the probability of x equal to 3. Now the probability of x equals to 3 now. Probability x equals to 3 will be equal to what? 9 combination 3 into 0.4 raised power 3. That's the essence of the PMF to give us the formula to use. Into 0.6 raised power 9 minus 3 is what? 6. Then we solve this. Then get your answer. I'm sure you know how to solve that. So that's 9 combination 3, whatever you have, then you multiply it to 0.4 raised to power 3, then you also multiply it to 0.6 raised to power 6. And what does that give us? So that gives us 0.25. So that's the probability of x equals to 3. Now the probability may not just be x equals to 3, it might be greater than or less than equals to. Now what the next question says, probability of x less than or equals to 2. Now what does x less than or equals to 2 mean? We can have from 2 to what? 2 to 0. 0 included. 0 included. When dealing with binomial distribution. 0 included. So less than or equals to 2. From 2, 1, and what? 0. So which means when x is 2, when x is 1, when x is 0. In the same formula. That's, let me just write the formula. That's P of x equals to 2. Will give us 9 combination 2 into 0.4 raised to power 2 into 0.6 raised to power 7. Then when x equals to 1, that will be 9 combination 1 into 0.4 raised into 0.6 raised to power 8. Then 0, that will be 1, right? 9 combination 0 is 1. Into 0.4 raised to power 0, this will also be 1 and 1, right? Into what? 0.6 raised to power what? 9, right? So this one is just 0.6 raised to power 9. Now, whatever you have from each of them, you now add it together. Then you get your answer for probability of x less than or equals to 2. So the probability of x less than or equals to 2 means from 2 to 0. You get probability of 2, probability of 1, and probability of 0. So if you do that in your calculation, you get your final answer. And what do you have as that? Are we done with that? What was our answer? Let's be fast. The time is fast spent. Two, three, one. Anybody else? 0.231. Okay. So when we add the three together, we have 0.231. So that's for number 9. Number 10 is also like this one. So I will not be doing number 10. I'll just give you the given parameter. For number 10, it says the probability that the seed germinates is 0.85. That's key. Probability that it germinates, that's probability of success. That's key. Is 0.85. If probability of success is 0.85, what will probability of failure? 0.15, right? Like 1 minus this. So that's basically the translate your question. I'm number 10 now. So if probability of success is 0.85, failure is 0.15. Now, if 8 seeds, what's that 8 then? The population. That's N is what? Now, if 8 seeds are being planted independently, find the probability that exactly 6 germinates. That means you are looking for probability of what? S equals to 6. That's the first one. The second one says at least 7. What does at least 7 mean? That's x greater than or equal to what? 7, right? That's at least 7. And maximum seed is what? 8. That means you are going for 7 and what? 8 for this one. So this one you do it yourself later. That's for number 10. Number 11 is also. Okay. I will explain number 11. Number 11 now we have to find the mean and variance. The probability like that. So let's see. Number 11 says for x. That BIN means binomial distribution. That BIN means binomial distribution. And we're given the binomial distribution, we're given 10 and 0.3. That 10 there signify n, and 0.3 signify the probability. Okay, number 11 now. We are given for x. I said you did number 10. But I've done that already. For x, binomial distribution, n is given as 10, and p is given as 0.3. Now, if p is 0.3, q will be what? 0.7, right? Now, we are asked to find the mean. E of x is the mean. For binomial distribution, the mean of binomial distribution is what? NP. It's just NP. Mean of binomial distribution is NP. While the variance is what? NPQ. For binomial distribution, the mean is NP, the variance is NPQ. Now, I'm sure you can do this. That's 10 times 0.3. and 10 times 0.3 times 0.7, you get your answer. So that's for binomial distribution, the mean and what? And the variance. Mean is NP, while the variance is NPQ. Then the third part says probability of between 2 and 5. If you do this one is 3, right? And this one is what? 3 times 3 is 2.1, right? Okay. That's for the first part of number 11. Now the second part of number 11 says probability of 2 less than or equals to x less than or equals to 5. What does this statement mean? And 5. But the equal to means what? 2 and 5 is being included. That means you are doing 2 for 3 for 4, like binomial stuff, just like that one. You do for probability of 2, 3, 4, and 5. Do you understand? You can also solve that on your own. Personal question. Then mode. Number 12 talks about mode. The first part says P of x greater than or equal to 5. You can do that one. The second part talks about mode. Now for number 12. Number 12 says a fair coin is being tossed 7 times. A fair coin is being tossed 7 times. What's the probability of success of a fair coin? Probability of success of a fair coin. A fair coin. Now, if I have a coin here now and I toss it once, what's the probability of me getting an head? What's the probability of me not getting an head? A fair coin, coin is having head or tail. Now, what's the probability of me getting an head? 1/2. What's the probability of me not getting an head? So for a fair coin, the probability of success and failure is what? 1/2. So which means for a fair coin, P is 1/2 and Q is also 1/2. So you will not be given, but once you see a fair coin, you should know that it's 1/2 or 1/2. That's for coin. Now it's been tossed 7 times. The number of tosses, that's n. N is what? 7. Now, if x is the number of heads, now we have to compute P of x greater than or equals to 5. What does greater than or equals to 5 means? Now, a coin is being tossed 7 times. If x is the number of heads, now we have to find the probability that we are going to get 5 or more heads, right? That means we do for 5, we do for 6, and we do for what? 7. Because the maximum toss is what? 7. So you do for 5, 6, and 7 using your normal binomial formula. You'll be able to solve that. By the time you get each of them, you add them together. Do that one. Now, the second part says the mode. The mode of the distribution. What is the formula for the mode of binomial? N plus 1 into N plus 1 into brackets P. Yeah. So the mode of binomial distribution is N plus 1 into brackets P. The N is 7, add 1 to it, multiply by. That's 8 times 1/2, that's 4, right? So that's the mode of binomial distribution. That's the mode. Then very quickly we can do the remaining ones so that we can complete this. So that's what we have in binomial and Bernoulli distribution. Now for hypergeometric, Poisson and normal distribution. Now the number 13 is hypergeometric. Yeah, 13 is hypergeometric, 14 is Poisson, 15 is also Poisson. Normal. Okay, I'll just give the formula for number. Now, for number 13, what's the formula for hypergeometric? For P of x. Hypergeometric now. P of x is given as hypergeometric. Is it not K first? K combination x. Kx. K combination x times, right? N minus K combination n minus x all over n combination n, right? So that's the formula. I sent it on to my channel. I'll send it to you. So n combination x times n minus k, capital N, is different from small n in this case. Now we are going to see what each of them means. Now the question says, a lot of 25 items, that's the capital N. The total population itself now is capital N. So N is 25 items. So a lot of 25 items contains 6 defectives, that's the K. Contains 6 defectives, that's the K. 6. That's the first statement. Now, a sample, the sample is the N, small n here now. It's different from binomial. Now, in this one, total population is capital N, while the sample is small n. So the sample, so a sample of 5 items is drawn without replacements. Hypergeometric is always without replacements. So a sample of 5 items is drawn without replacements. Now let y be the number of defectives, like y instead of x now. We have to find the probability of y equals to 2. Now probability of y equals to 2. Now if you use this now, we are going to have k combination y, right? That's 6 combination 2 times n minus k, 25 minus 6. That's what? 19 combination n minus x, 5 minus y, that's 5 minus 2, that's 3. Or should I write it again? Let me write this. Now n minus k, our n is 25 minus our k is 6. Then n minus x, small n minus x, 5 minus x is our y here, minus 2. That one is there. All over. Now capital N, our n is 25 and our small n is what? Is 5. So we are going to do this. So that's 6 combination 2 times 19 combination 3 divided by 25 combination 5. So you get your answer. If you do that, let's make also here. 6 combination 2 times 19 combination 3 divided by 25 combination 5. 0.27. That's the probability, right? Now, how do you know if your answer is correct? Your answer must be between 0 and 1. So, if you are getting something bigger than 1 or less than 1, note that there is a mistake in your working. Because we said ranges of probability is what? Between 0 and 1. Okay. So that's the first part of that question. So P of y equals to 2. The second part says P of y less than or equals to 1. What does less than or equals to 1 mean? We do for what? 1 and 0. So we do for 0 and 1. So meaning when your y is 1, put it here. Like put it into the formula. Then when your y is 0, put it to the formula also. Then you add them together. That's what this statement means. You can also go through that. So that's for hypergeometry. At times, you may not see it as a working. You might just add something based on the formula itself. You might just add something based on the formula. I think I saw something like that. Like just based on the formula to know whether you understand it or not. And you might just also see it also as working. In any case, it might be. Now, I have a question here. If outcome A, are you listening? If outcome A is not affected by outcome B, then it is what? If outcome A is not affected by outcome B, then events A and B are what? If A and B is an event, now outcome A is not affected by outcome B. So events A and B are what? Independent. Independent. Meaning that they are not affected. So if outcome A is not affected by outcome B, so events A and B are independent. Okay, there's also a question. Normal distribution is symmetric about dash. Normal distribution is symmetric about dash. Normal distribution is symmetric about dash. Variance, covariance, mean, mode. Normal distribution is symmetric about dash. Normal distribution is symmetric about dash. Variance, covariance, mean, mode. Mean is the answer. Normal distribution is symmetric about mean. Okay, now to Poisson distribution. Don't want to move this. We are done with this. Now for Poisson distribution, that's number 14 now. So for number 14, the number of customers arriving at a shop per hour follows Poisson. Lambda is 5.5. The number of customers arriving at a shop per hour follows Poisson distribution, which is lambda equals to 5.5. Now find the probability of exactly 4 when x equals to 4. Find the probability that exactly 4 arrives. Now, what's the formula for Poisson distribution? The P of x is what? P of x is what? Poisson. Exponential minus lambda times lambda raised by x all over x factorial. That's what Poisson distribution. Now, from one question that I saw, the question is based on the formula now. What does lambda represent? What does it represent in this formula? The rates. We've said it in the question now. The rates of the occurrence. Lambda represents the rates of what? Of the occurrence. So note down when you see it. So lambda in Poisson, lambda represents the rates of occurrence. And you know in the computer there is no exponential, right? And exponential is what? It's some, say some. I don't say it. Means, okay. Exponential is 2.718. Am I correct? Am I correct? Yeah. 718. Is it correct? No, it's 2.1. I'm correct. 2.718. So when your system doesn't have exponential, so if you do 2.718 raised to the power minus, you can do that on the system now. So instead of, I'm not sure some of the exponential is, but when you know this one, so 2.71 is raised to the power of minus. So now, how do we get the probability of exactly 4? Yeah. That means it will give us exponential minus lambda, that's minus 5.5 times 5.5 raised to the power of 4 all over 4 lambda. That's how we solve this one for Poisson. So probability of getting of exactly 4 customers arriving. So that means when lambda is 5.5 and x is 4. Exponential minus 5.5. You can check with your calculator. Use the two methods. Use exponential and use 2.718 raised to the power of minus 5.5. You also get an answer. That's 0.004. Then multiply it by, me I'm using the 2.718 now, you can use the exponential. Times, I don't know how to use it. Times lambda raised by, that's 5.5 raised by 4, divided by 4 lambda is 24, divided by 24. My own answer is 0.16 approximately. What's your own? Now let me use exponential. Exponential, or you don't have to use exponential. Exponential raised to the power minus 5.5. I have the same thing. Times 5.5 raised to the power 4. Divided by 24. 0.16 also. Do you get that? Or you don't have to get exponential. If you couldn't use exponential, use E now, which is 2.718. So do 2.718 raised to the power of minus 5.5 times those ones. You still get the same answer. So that's for Poisson distribution. Then second part of the question says, at least 6 arrives. What does at least means? At least 6 means what? At least 6 means what? X at least 6 greater than or equal to n. So it may not always be given in written form. It will be in statements. You need to interpret it. So at least 6, at least. You can have 6 or more, right? That's greater than or equal to what? 6. Now, for the total, exactly 4 arrive, then at least 6 arrives. The number of customers arriving at the shop is this. Find the probability that exactly 4 arrives. Now, what's the probability that at least 6 arrives? Now, if at least 6 arrives, now, do we know the number of customers that will arrive? Huh? No. So we don't know that means 20 minutes, we don't know. But we can still get it. How can we get at least 6? Now let's get less than 6. Then take it away from what? From 1. Because at the end of the day, the probability must be what? Must be between 0 and 1. So you may not be given the total number of customers. This one for example. Total number of customers that will arrive. It's just like a real life situation. You open a shop. So what the probability that at least 6 customers came to your shop in a day? So you know the number of customers that will come. But you can know once you know 6, like at least now 6. So get the ones from 0 to what? To 5, right? Then take it away from 1. So that is the probability that more than 6 or 6 more than arrives in the shop. So that means we are going to do for 0 to what? To 5. Like in this same formula, if you are doing for 0, that will be exponential minus, this one remains the same, times 5.5 raised to power 0 all over 0 factorial. What is 0 factorial? 1, not 0. 1. So this is how you do for 0. Then you do the same thing for 1. For 1 will be exponential minus 5.5 times 5.5 raised to power 1 all over 1 factorial. And what's 1 factorial? 1 also. 0 factorial, 1 factorial is what? 1. 2 factorial, 2. 3 factorial, 6. Like that. So you do for 0, 1, 2, 3, 4, 5. So when you do for 0, 1, 2, 3, 4, 5, you now add them together. Then you now take it away from 1. Now the 1 minus answer. That's how you get for this one. At least 6. So that's how you get for at least 6. So you do from 0 to 5. Then whatever you have, add it together, then take it away from what? From 1. You get to answer to that question. Because you don't know the maximum number of customers that will arrive. Then the third part, just to translate the question, says probability of no more than 3 arrives. What does that statement mean? Probability of no more than 3. Probability of no more than 3. What does it mean? X less than or equals to 3. You can also do that too. So x less than or equal to 2. You know, by the time you are solving this one, you already have your from 0 to 3, right? So you just add those ones only together. So probability of no more than 3. You can have 3, but not more than. That means from 0. You may not have any customer. You may not have any customer. You can have 1, you can have 2, but no more than 3. That's probability. That's what that statement means. You also put it in the formula you solve. Then number 5. I'm not doing number 5, I'll just explain to you. You got number 5 now. If x Poisson is given, lambda is 4 for this one. I just want to explain, I'm not solving it. Lambda is 4 for number 15. We are number 15 now. For Poisson, lambda is 4. Now if lambda is 4, we have to find the probability of x equals to 3. So we can also find it, right? So this is lambda is this. So we're also finding x equals to 3. If x equals to 3, that means exponential minus lambda minus 4. Then 4 raised to power x, that's 3, all over 3 factorial. That's how we solve for probability of x equals to 3. That's for number 15, the first part. Now, probability of 2 less than x less than 6. What does that mean? Number 15. We have defined probability of 2 less than x less than 6. What does it mean? 2 less than x less than 6. 2 less than x less than 6. What are we solving? So since there is no less than or equal to, no less than or equal to, so it's just what's in between. That's 3 to what? 5. So you do for 3, 4, and 5. That's the statement then. You solve that one. Now the third part now says find E of x squared. E of what? X squared. Now, I want to show you how we got the formula for E of x squared. For Poisson distribution, the mean E of x is what? Lambda. That's for Poisson. For Poisson distribution, E of x is what? Lambda. Then the variance is also what? Lambda. They are the same. For Poisson distribution, mean is lambda. Variance is also lambda. But now, how do we now get E of x from that formula for variance? Remember our formula for variance. It's like V of x is equal to what? E of x squared, right? Minus what? minus E of x squared, right? And we know that variance is what? Lambda, right? E of x is what we don't have. E of x squared. We don't have it, right? Then we have mean squared. That's lambda squared, right? Now, if you collect like terms, that means E of x squared is what? Lambda plus what? Lambda squared. Am I correct? If lambda squared comes in, so that's how we get the formula for E of x squared. So E of x squared is what? Lambda plus what? Lambda squared. Normally the mean is lambda, variance is lambda, but E of x squared itself, we use the formula for variance to get E of x squared. We now get what? Lambda plus lambda squared. If you have to get that from this question, that would be what? 4 plus 4 squared, right? Since our lambda is 4 plus 4 squared, 16, 4 plus 16, 20. That's 20. So it's as simple as that. And lastly, the formula for normal distribution is what? What's the formula for normal distribution? It's given as z, right? Z equals to what? Normal distribution. Formula for normal distribution. Z equals to what? X minus or plus? Minus. X minus what? Mean. So x minus E of x. All over what? Standard deviation, right? X minus E of x minus mean. All over standard deviation. In some cases, you may not be given your standard deviation, you might be given variance. And no standard deviation is what? Square root of variance. So square root of variance is standard deviation. So that's for normal distribution. Although it's more than that, though. That's the part that I know. And other parts. Okay. So that's for that one. Possibly a date of the exam, we will do online quiz as we normally do it to cover the theory parts as usual. So that means that's everything about. So we are no more doing stats and physical class. The next one is the quiz. We do it a day to day. But the other one will be doing